What up, y'all? Jesse Warden here. We're going to do some simulation creation. What does that mean? It means we're going to create a program, right? A simulation is just a fancy term for a computer program that acts like a real-world scenario, right? So all we're going to do is write some code that does stuff. And stuff is defined as printing neat things to the console, okay? We've learned a lot of abstract concepts, variables, loops, functions, if-then statements, operators, blah, 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 but we haven't really put them together to build anything, right? So, like, these are all the Minecraft blocks, and that's it. Like, you don't get to play with them, right? It's kind of lame. So, I'm going to build a simulation today to show you how you can take objects and put objects in them, how you can take objects and put functions on them, and how we can build these really complex data types that actually store data and do things, and then write a program around it to make them act a certain ways, right? So, going to build some complex things and then give them behavior. You really need to understand all these basics. So as we talk about more advanced programming concepts, you can understand how these things interact. You can understand the basics of object creation, function creation, and how you assemble them into more complex structures, right? Additionally, once you build these complex structures, you need to make them act. You need to react to them making things, to doing things, etc. Reusing the algorithms, functions calling functions, yada, 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 all that stuff. So this is like kind of a demarcation line for the advancement of certain levels of JavaScript developers. So once you get beyond this, you are already in a large pool of advanced programming. So you should feel really good about yourself. Even if you don't have the experience, that's okay. Most people don't delve much farther than this. So you're already getting to the point of advancement. All right, so let's write some algorithms, okay? What we're going to do from a high level is we're going to create a series of gladiators that battle each other. And each gladiator has different attributes that make them good at one thing and bad at another. Then we're going to add some randomness to make it exciting, okay? It's always exciting in head. So the first thing we need to know is how do we deal with numbers and randomness? Well, there's this wonderful class in JavaScript where object that has a bunch of cool functions and shows up in blue in our editor called math. Math is the crux of everything, right? But the fact that they gave us a math object that is very common math operations is something that you need to be aware of, okay? So here's basics of math. Math.random gives us a random number, okay? So we can play actually in the, here, let's clear this out. So we can play with it here, and you can see that it always gives us a random number between 0 and 1, okay? Very rarely will you see 0, and very rarely will you see 1. The point of math.random is to utilize that randomness from 0 to 1, or if you multiply it by a percentage, it's 0 to 100, right? You can use a percentage chance of a random percentage that you can multiply by any number to get a random number. Right? So most people say, well, I just want a random number between 1 and 1. Well, you could do that. You could write a function that does that. We're going to use this as the crux of our randomness, and we're going to follow a certain set of rules called D20. So if you're not familiar with D20, D20 is an open source gaming system utilized by dice or die, right? And these dice or die, when you roll a die on a table, usually random, right? Based on the randomness of your throw, wind systems, humidity, table surface, your current mood, right? So if you roll a 6-sided die, it's randomly going to go from 1 to 6, right? It's always going to be an integer. You can't land on half of 1 and 2 with a die. It's got 6 sides. It's going to land on one of those flat sides, 1 through 6. There are other shapes of dies, right? There's a 1d4, which is a 4-sided die. There is a 20-sided die, etc., right? There's a variety of different ones. So we're going to write our entire system based on this concept of dice. And using those dice and the randomness of what they could possibly land on, we're going to simulate that in programming, okay? So we're going to write our roll dice function, and this algorithm has how many dice are we rolling, right? So we're going to roll 1 6-sided die or 50, right? And then we're going to tally those numbers up. Also, what type? Is it a 6-sided die? Is it a 4-sided die? 10-sided? Whatever. This also allows us to do a penny, such as a 2-sided die, right? You flip a coin. We can also do 3-sided dies, which are kind of weird looking. They actually look like stretched diamonds, but anyway. So the way it works is we need to get a result that's local, okay? We just care about that particular roll. So we're going to start with 0 and then add up subsequent rolls from that. So we're going to use a for loop because we're going to assume that we're going to have more than one or many, many different die. We need to loop through each one of those and roll each time, right? So if we have 6 6-sided die, we got to roll these dice 6 times. and constantly re-add the sum of those numbers. So we're going to use I. You should never use I. I is an iterator. You should use something as increment, right? Increment, but I'm lazy, so I like to do this. And it's more optimized JavaScript. How many times do we loop? How many times? How many die are we rolling, right? So we loop that many times. Now you'll notice here that we can't do many different types of die, and that's okay. For now, we're just going to assume that we're going to roll many times the same set of die, okay? We're going to increment. And I apologize for the delay. I've had allergies for 5 days. I live in the South. We have this thing called pollen and ragweed and all kinds of other allergens that appear beginning and late of summer, sometimes around fall. As you can tell, I'm a little stuffy. I'm a little out of it, but I've got lots of coffee. A positive attitude and a desire to build. And that's all you need. You know what I'm saying? That's it. You got that, like you can just, you know, build a bunch of dirt squares and you're up in the sky and you're looking around and you're surveying your vast kingdom and all those creepers and skeletons. Crazy. Alright, math.floor. So we're going to take our result and add it to the existing result. So let's say, what's our role here? Our role is a math.random times what type. So for example, if we have a 6-sided die, it's going to be 0 or 1. So it's going to be anywhere from 0 to 6. That's the problem. We don't want 0. We want 1 to 6. So we can get around that by adding a 1. So we can get a number from minimum of 1, if math.random ever gets 0, to 7. We don't want 7, right? We don't want that. So what we can do is we can actually floor the result. So if anybody knows what floor is, that is round down. So round down whatever you roll. It's going to be anywhere from 0 to 5, okay? Then add a 1. So it's 1 or 6. Perfect. That's the range we want. So this is our algorithm for rolling dice, okay? Then we're going to take that result and add it to what we already have. So whatever you roll, just add it to what we already have. The first roll is always going to be 0, so you're always going to have a minimum of 1 to 6. If you roll multiple die, you're going to keep adding to that as the loop continues on. If you only have one iteration in your loop, fine. You roll 1d6, cool, that's your result. You're done. You return it. So this algorithm is the crux of our entire system. Okay, so we're going to write a lot of code, a lot of functions today. And this is the main dude. Let's have fun. Programming is about fun. You should always have fun programming. If you're not having fun, then you know you're having a bad time. And sometimes there are bad times in programming, but the goal, you know, is to wake up in the morning and enjoy this stuff. All right, so we're gonna roll our dice. Let's test it out. So in Dungeons and Dragons nomenclature or Pathfinder, they have something called 1d6 or 1 6-sided die, right? That's how they say it. Or 2d20. That's 2 20-sided die. So we're going to do that. We're going to do 1d6. We're going to do 1d20. And then we're going to do, let's do 3d4. 3 4-sided die. I'm going to do another cheat here, okay? This is horrible, but I'm lazy. So we're going to make a wrapper function. A wrapper function is a function that wraps functionality for a variety of reasons. You can wrap it to abstract away complexity. So for example, I have this teensy little function does all of this, right? It does a dice rolling. Or you can wrap it to make it smaller or easy to read. So for example, I could wrap roll dice into RD, A, B, right? Instead of, I could write RD instead if it called roll dice, right? How many, what type. So your code is tighter, fits smaller. The problem with that is it's unreadable, right? Some wrapper functions want to do that on purpose, and that's because I'm lazy to type, right? So watch this. We'll go console.log. Oh, so now all I have to do is D. So instead of typing console.log all day, I can just go D. D is a short euphemism for debug, right? There we go. Let's return the result because I broke it because I'm silly. There we go. So we've got random numbers. So the first number is going to be 1d6, right? We're always going to have a 1 or a 6 or 2 or 3 or 4 or 5 or 6, right? Never going to go over. If we ever see a 0 or a 7, we should be concerned. But we won't, because our algorithm is legit, because I'm an expert coder. No one was listening. The second one, 1d20, it's going to be a random number between 1 and 20. We can sit here and apple our life away. Know that our math.random, for the most part, is random. It's not really random. There are seeds that it utilizes. I think it's like the daytime, which is like controlled by the computer clock, which isn't really random. And they give you the option to provide your own seed. Is a seed that uses math.random to determine what the random number is. But who cares? As far as we're concerned, it's math.random for now. Maybe they could change it in the future. Who knows? All right, we're going to program to the API they give us. 3d4 is going to be a minimum of 3 and a maximum of 3 times 4, which is 12. Right, so it's going to be 3 through 12. Right. Okay, so we've got our roll dice function. We've got our nice little algorithm working on. That's cool. It's awesome. Now, what we're going to do is going to create our gladiators. Our gladiators are our objects, okay? An object is another word for a struct or a structure or a data type that holds complex data. So numbers are not very useful. We can't say, hey, that's a gladiator. Oh yeah, what's his value? 1. Well, that's ridiculous. We need to say he's a gladiator who has these certain attributes, okay? So we're going to create one right now. We're going to say gladiator 1, okay? He has an attack value of 10. A defense value of 10, and hit points of 10. Cool, so he now has a variety of properties. Let's give him a name. Everyone should have a name. Jesse, you're an average run-of-the-mill gladiator. Thanks, appreciate that. What about Russell Crowe? He was not average run-of-the-mill. Well, you're not Russell Crowe, bro. Well, I can kind of talk Australian. All right, so Gladiator 1. He has 4 attributes. We don't really care about name right now. What we care about is attack, defense, and hit points. Now, these numbers are going to have some business rules or algorithms based around how they interact. So what does that mean? So for example, a gladiator or fighter or any warrior, right, utilizing pre-gun technology is going to have some form of attack. This is his ability to skillfully take the pointy end of the sword and stick it in the other opponent, right? And hurt him and attack very well, cause as much damage as possible. That is the attack value. It represents a numerical scale from 0 to whatever, 100, whatever. Higher the number, the more skillful he is. The lower the number, the less skillful he is, okay? Defense, it's skillful, full. Defense is how deft he is at utilizing his current skills to dodge that attack. That's everything from utilizing the weapon he has to defend, whether you're using a shield to block that attack. For example, flails, you know, the little balls on the end of chains were actually developed to help get around shields. So you'd hit the guy with your stick, the chains would wrap around and hit his arm from behind. Now, if he has armor on his arm, not so helpful, but right? So he knows that when defending against flails, for example, right? Whereas a less skillful opponent, even if he had a shield, wouldn't know that from flails and would probably get hit, right? So defense represents that ability to recognize how you can deflect certain types of weapons, your skills around that, and things like that, okay? That's defense. And if you just have a bunch of armor, even if you suck, you know, at fighting, you're still awesome because you have like a bunch of metal. And you're like, rah, rah, like Iron Man, right? Okay? That's defense. Hit points represent, and they're really a silly thing, but they represent the experience that you have in battle, right? The more experience, the less likely you are to die, even if you get hurt, right? You won't panic, you won't bleed out, you can, you know, bandage yourself. If you get hit, you know how to take a hit and roll with the punches, that kind of thing, right? That's hit points. Higher the hit points, harder you are to kill, okay? So there's the 3 main things that we care about: attack, defense, and hit points. That represents our gladiator. Our entire system is going to be built around those particular attributes. You got it? So that is our object, or our gladiator. Okay, we're defining abstract things in code. Now, this is what's so great about coding, is that my interpretation of how to code this may be different from yours, and that's fine. That's why this software, they call it software engineering, to understand the concepts, to utilize the correct terms, to talk about computer programming terminology. But it's an art. It's an art. If you use your tools, right, to build a program, it's going to end up differently. And that's because you have your own preconceptions and your view of the world and your knowledge and your experience. And it's going to be different. And so that's why this is an art form, okay? It is not a science that, you know, has rigorous testing tools, because if it was, you wouldn't have so many computer things that fail, computer projects that fail. All right, so that's Gladiator 1. We're going to make Gladiator 2 here. And this is going to be my dog in tiger form. So his attack is 14, but his defense, not so much. He's old. He's not very fast. Whatever else. And his hit points are, let's say, 8. Nah, let's say 14. He's a tiger. Tiger uppercut. All right. So that's Toby. Now, how do we determine if somebody hits somebody else? Well, we have something called an attack roll. An attack roll utilizes a 20-sided die. And it says, all right, take the attacker's attack value, subtract it from the defense. He has to roll that particular number or higher to hit, okay? So the attacker is the person who's trying to hit the other person with whatever weapon they have equipped, doesn't matter, against whatever the armor the defender has. Attacker and defender. This person wants to attack this person. Okay, so the 2-hit number is the number that he has to hit or above to hit, right? All positives here. Low number's bad, positive number's good. The 2-hit number is the defender's defense minus the attacker's attack. So, if the defender has a defense of 14, I have an attack of 7, then I have to hit a 7 or above on a 20-sided die to hit, right? That is the 2-hit number. So let's make an attack roll. Now, the randomness is, what did I roll? Did I roll a 7 or above? Cool. But I could roll less because the D20 could just give me a random number lower. I could roll a 1, 2, 3, 4, 5, or 6. That would be bad. Okay, so the attack roll is, our roll is a roll dice. Now you notice I'm using functions, calling functions here, right? Our first function, it's going to use our base algorithm. Everyone's going to use this base algorithm. Roll dice, just like everyone uses the base math algorithms, right? You build functions to build functions that use other functions. You create this nest of functions, and you try to keep all of this complex program in your head. That's called cognitive load, right? Now, when you first start programming, it's hard to keep this much code in your head, keep track of what it does. Over time, it's just like a muscle, right? You have something in muscles called proprioception. It's called muscle memory. After a while, your muscle gets really good at doing a certain action. Anything from strength training, like when you're doing, bicep curls, to when you're doing running, right? When you're doing good running form, right? Don't break the glass, keep your head up, lean slightly forward, balls of the feet, that kind of stuff. Your muscles actually learn after a while to do things without you even thinking about it. Now, there's theories about quantum mechanics, but blah, blah. The point is that you can teach yourself, teach your body to memorize those things so you don't have to, right? Programming is the same way. As you exercise your brain, there's 2 main things you have to remember. And that is, A, you have to memorize the API, right? And how things work, how for loops work, right? Additionally, you have to exercise it. And that is doing this over and over again. Eventually, as you write more and more programs, they'll get larger and larger. You'll be more capable of keeping that program inside your brain all at one time. So you can easily reference, oh yeah, the roll dice does this, and that does this, but I got to call this first, so I do this, right? You'll be able to hold that in there. Now, this can take anywhere from 5 to 40 minutes to be able to get a program in your brain of various sizes, right? And you'll be able to get bigger and bigger as you get time. So if a lot of this is really hard to keep in your head at one time, don't worry about it. Just focus on the one particular part. Over time, you will get stronger. Your mind will get stronger, just like your muscles get stronger when you work out, okay? Same with cardiovascular, blah, blah, blah. All right, so our attack roll is a roll. If the roll is greater than or equal to the 2-hit number, return true. Return false. Now, here's the problem with reading code, okay? Attack roll says, cool, but we're returning a Boolean. We should make a function that kind of imitates or illustrates what it does to its name. So, for example, roll dice. We would assume that roll dice would return some form of result of what we rolled, right? For the most part. attack roll doesn't really say that, so we should more ask, did hit, okay? If it did hit, cool, return true. If it didn't hit, cool, return false, right? So did hit? No. Did hit? Yes, right? A little more easier, more English, okay? Now remember, Jesse Warden, not so good at English. You may be better. So the more verbose the function, the better. I make them very verbose because of my elementary control of the English language, right? So now we know we have an ability to roll dice, variety sizes. We now have the capability of identifying if a gladiator attacks someone or not, and did they hit them. Cool, so let's deal with damage. What is damage? Well, we're going to do our first objects with an object, okay? By default, if I hit someone with my hand, with my man hand, my ham fist, right, it'll do 1 to 2 points of damage, right? I can hit him hard or I can hit him really hard, right? I can just get lucky and hit him in a part that hurts, okay? If I use a weapon, something that's designed to kill, right, it'll do a significantly huge more amounts of potential damage. So the weapon we're going to utilize for Gladiator 1 is dagger. Now you'll notice I haven't defined dagger yet, and that's okay. We'll do that in a minute. Okay, this is kind of when you design your program in your head, or you start to use something called pseudocode. It's code, but it's not really code. It wouldn't actually compile or run, right? So you're still figuring it out, okay? You shouldn't stay in pseudocode land too long. You should try to get something constantly showing to the screen, you know, quickly iterating as best you can. Sometimes the problems get larger. It's harder to do that. That's okay. Again, it's all about exercising the brain, right? Cryoperception of your memory for cognitive load purposes. His weapon is not a dagger, but a claw. It's the claw. The dubstep claw. And Richie August. Well, they're not really together anymore. It's too sad. Alright, so calculate damage. So we've identified that they have in fact hit. Cool. So what is the damage? All we need to know is the attacker. For now, we're not going to deal with damage actually reducing damage. For now, armor just determines if you hit somebody or if you attack somebody in plate armor with a dagger, most likely you're not going to hurt them. In leather, you can hurt them. You can probably hit them. There's certain points in leather armor that can be pierced, right, if it's boiled hard. So once you've hit, we're just going to calculate damage. Damage is calculated the same exact way on a dice, right? You roll a die, and it gives you a value. But what is that value? Damage roll is the attacker's weapon. Get damage. Okay, get damage. Well, what is get damage? Well, let's define these weapons and just say off the top of our head that every weapon should have a function called get damage. Each weapon is going to return more or less damage compared to another. So for example, a teensy little stiletto, it's a dagger that's really small, about this big, is not going to deal as much damage as a claymore, which is a gigantic Scottish sword. Huge. Let's say a dagger. And again, you'll notice that Jesse Warden is cuddling today, right? Some days I do this, other days I do this. It's okay. As I've gotten older, I've not cared anymore. When I was young and had lots of attitude, that was a big deal. I'm being consistent with code and objects, and now it's a deal. You find that as you learn more and you get more experience, that certain things that used to matter for life and death of projects and don't. That's okay. It's good to care. It's good to have a good attitude. It's good to be consistent code. That's great. Those traits should never go away. Just like youthful exuberance. And good attitude. Cynicism. Waxing poetic, sucker. Alright, so we're going to give him his get damage function. And he's going to return a dagger is roll dice, right? Function using function. 1d4. So dagger is anywhere from 1 to 4 points of damage. If I get a really good hit, it's 4. Otherwise, if I just nick somebody, it's about the same as hitting them really hard, right? So that's dagger. Claw, actually, yeah, claw is slightly more powerful. Than a punch. So we're going to say return roll dice 1d3, okay? So that's a claw. So Jesse's wielding a dagger, and Obi-Wan Kenobi, as a tiger, is wielding a claw, which is 1d3 points of damage, right? So Toby has a higher chance of hitting, but he's also easier to get hit. Jesse's about average, about both attacking and defense. And Toby is harder to kill. So even though his weapons aren't as good, you know, likelihood, 1 hit point, whoopity-doo, he's more likely to wear down Jesse more quickly, okay? So those are the odds. You can calculate that in your head. Now that we have damage, let's return it. Return the damage roll, okay? Now, the reason we encapsulate this in here rather than call the weapon directly is that we need to know the attacker's weapon. Later on, we can add more complex rules to allow the attackers to get bonuses for certain situations that may occur. Maybe they're tired, or maybe they get really mad when they're like bleeding profusely. Maybe there's some kind of magic potion they can drink that when they have full hit points, they do more damage, but as they get less, they don't. Who knows, right? So we're giving ourselves an out. We're giving ourselves the capability to extend it later without changing the actual function. So somebody could calculate damage. Later on, it actually returns more damage. We just don't know that those bonuses are happening internally. This is why functions are really good at encapsulating algorithms, right? We can play with the algorithms, and the actual people who call them down here don't change. The API, the application programming interface, or the way you call these functions doesn't change, okay? Usually. Sometimes change parameters blows everything up. All right, so we have a capability of determining, did an attacker hit a defender? And if so, how much damage did he deal? So let's test them both out. Let's just do D, did hit Gladiator 1, did he hit Gladiator 2? Okay? Do the same exact thing right below it, except have Gladiator 2 attack Gladiator 1. Alright, so now that we fixed our claw to actually be an object, right? I had some bad syntax there. Once we fix that, now we can test it out. We say true, true. So they both hit each other, okay? So let's increase Jesse's armor. Let's say he put on plate mail with a plate mail hat made of steel. He is nearly impossible to hit. That means that you take his defense of 20 minus Toby's attack value of 14, right? Again, the algorithm is Jesse's defense, which is 20, minus his attack, which is 14. Still, for the most part, Toby one's always going to hit. See the second one in false? Very rarely is he going to get a false. As you can see, I'm constantly refreshing here, and very rarely is he missing, even with plate mail. So let's make it a little more interesting. We'll take the attack value of 2 and make Toby's attack value of 4, so he's a little bit better than Jesse at actually hitting. Jesse's defense by default is 10, and Toby's defense by default is 12. He's got fur, he's tough, right? Make it a little more random. There we go. True, false, true, false, true, false. Toby, for the most part, is always hitting. Jesse, very randomly hitting. But once he does hit, he does a lot more damage, right? So it makes the fight a little more interesting, okay? So that's the value. Okay, cool. So we know that our calculate did hit function is working out pretty well. We can tweak the values to play with those results and see, you know, how can we make him hit more? How can we make him hit less? How can we make the fight more fair and interesting, right? Interesting, again, is the randomness part of it. All right, now let's do the damage. Damage, again, is just a roll. Obviously, it works, but we're going to test it because you should always test your JavaScript functions because you'll find misspellings, things like that. Again, JavaScript is a evaluated language, and what that means is the code doesn't run or do anything until you actually run your program. Run your program is just mean refresh your file in JavaScript and call the main function, right? So if you don't do that, you won't get compile errors, you won't get errors shown, things like that. Now, there are tools that I'll show you later that will do this for you, but unfortunately, you have to actually constantly refresh to make sure that you didn't, you know, screw up a semicolon or whatever else. The more often you do this, the easier it is to find issues early. You saw my claw, it looks, if you go back to the video, it looks nothing like what I wrote, right? And that's because I refreshed it early, I can find the problem. It's easy to find in all this code I wrote because I'm already familiar with this, right? So that's why you should constantly refresh just to make sure that your code is still working once you're done, right? Once you reach the point where you're ready to test it. So we're going to calculate damage on Gladiator 1 and calculate damage on Gladiator 2. So they both roll a 1, 2, 4. You can see Toby is constantly getting 1 to 3, and Jesse's getting anywhere from 1 to 3 to 4. Okay? Totally random, but Jesse's more likely to get a higher damage, hopefully, because he has the capability of doing 4. Right? If he gets a 4, that's great. Will it make the difference in a fight? Probably not, because the odds, for the most part, are stacked against him. Easier to attack, better defense, right? Toby's really got it going, but we're going to be cheering him on, so think positive. Think positive is not going to affect the computer. But I don't care. I always think positive. All right, so we have a calculate damage. So now let's orchestrate this whole concept of making an attack. So we'll say handle attack. The attacker wants to attack the defender. We're going to put everything we just did all in a function to encapsulate the entire algorithm of one person attacking another, and if they did hit, actually applying the damage. Okay, so let's do that. Let's go did they hit, attack did hit, which is our internal function, right? Attacker, defender. So we just merely pass the exact same two parameters that we passed in to the function of did hit, right? And we're calling did hit. You don't have to define this after these functions. I just like to, you know, kind of write the program with smaller pieces up top and then as it grows later on for simple programs. That's not how classes work. Classes are a little different. But we're just having fun building crazy stuff. Okay? Did they hit? If did they hit equals true. Now you can do this in some browsers, right? You can just do if did it hit, but it's not very clear as what the code does. You should always be explicit. If somebody has to think reading your code, if you have to think reading your code, that's a problem. There's a book called that I encourage all y'all to read. It deals with building good software. It's about usability. Usability and user experience is still a much neglected topic in our industry. Steve Krug wrote a really approachable, easy, small, short, you know, less words per page book called Don't Make Me Think. And its applicability to writing programs is accurate to a T. If you have to think when using a piece of software, they designed it wrong. You know, help manuals, things like that. There's always going to be a point where a user has to learn your program, and that's okay. But there comes a point where you're designing software that should be easy to use, right? And mostly discoverable by a user. Things that they expect. They expect scroll bars to work, you know, a certain way. Don't make me think mentality applies to programming as well. If you have to think too hard or you have to be clever, you know, feeling clever is good because it shows you're learning. But if you do something clever in code, usually that means the other guy, or even you later, months later, have to figure it out. And this is generally not good, okay? It should be easy, simple. But some algorithms are just hard. You know, some problems that you're solving in the real world are hard. You have to take clever solutions. And that's just, you know, the pragmatic that it has to be, okay? So if they did hit, then let's apply the damage. We're going to calculate damage on the attacker. How much damage? And then we're going to take the defender hit points and minus their value to how much damage he actually did. Okay? So if the defender hit points has 14 and he does 4 points of damage, he's now going to have 10. When he gets to 0, he's dead. So let's handle that. If the defender that hit points after applying damage are less than or equal to 10, because you can do so much damage he gets to negative hit points, right? These are numbers that are unsigned bit, 64-bit numbers, both positive and negative, right? If you don't know what a negative number is because you haven't gotten that into math yet, don't worry about it. So for example, it's 32 degrees outside if you're in America, or it's 0 degrees Celsius if you're outside of America. You actually use something called the metric system, which is amazeballs versus the horrible one that we use. So if it gets colder than 0 degrees or colder than 32 degrees, what happens? Temperature keeps going down, right? It keeps getting colder. In Celsius, it goes to -1, -2. In Fahrenheit, eventually it'll get to 0 and keep going too, right? These are numbers that are less than 0. They're still on the same scale. It's just they're represented with a negative in front of them or a minus sign, right? So you're not actually doing subtraction. It looks like it, but you'll get it. So if our number goes less than 10, I'm sorry, less than 0, right? Then they're dead. So game over, man. And let's pass in who died. Game over, man. Game over, man will stop our game. Game over, man. Okay, so how do we store our game? Well, let's make an array which represents the arena, okay? And the arena is all the participants. So I'm going to put this variable at the very top. Call it arena. It's an empty array, right? The arena is empty. There's no one in it. No gladiators, no animals, no nothing. And we're going to say game over, man. We're going to make a function called start game right above it. Let's pull our gladiators up there. Okay, we're going to cut, paste. Cool, so we have some gladiators, okay? Let's make 2 more gladiators. Gladiator 3 is Her Majesty. Her attack value, because she's a nice girl, is 1. However, her defense is going to be 14. She's wearing some awesome leather armor. And her hit points are about the same as mine, okay? Her weapon is a halberd. Halberd. I probably spelled it wrong, but I don't care at this point. And Gladiator 4 is... who should it be? Who should it be? I know. Bruce. After my favorite actor, Bruce Campbell. This is my favorite. Like, maybe he's my favorite. I don't know. Alright, so his attack. He's a pretty skilled guy. Is 5. His defense is 11. He's got some tattered leather armor. And his hit points are, let's make him 12. Okay? And his weapon is boomstick. Alright, so those are our gladiators. We're going to add those to the arena. So we're going to go arena. Now you can do a push, a multiple. I've showed you, advanced JavaScript. We can say Gladiator 1, right? We're going to add them all to the arena. But you can also just do this. So if you do that, you can do them all in one line of code. So let's cut this out, put this in start game. Sorry about that. And let's call start game and see what the arena equals. So you can see, oh, halberd is not defined. Let's make our halberd real quick. Let's take our weapons. See, and this is what a lot of programming is, just writing code, right? The majority of your day is either spent, depending on your industry, writing code or fixing code. Right? It depends on what your style of work is. If you work in a design agency, typically your projects are anywhere from 2 weeks, 1 week to 6 weeks, maybe even three months, right? But you always get a new project in there. You're writing a lot of new code. Very rarely are you maintaining existing code. If you're in a startup, you're constantly writing code, deleting code, starting again in a different direction. If you're an enterprise or larger company, you're often fixing code or modifying code. You're not writing a lot of new code towards the end of the project, right? And these software programs will last for years, right? So it depends on what you're doing. But if you're playing after work or having fun, you're always writing code. Right? You're always writing code to learn everything else. So a halberd is a big, long stick with points on it. It's a big, gigantic spear with awesomeness. So we're going to return a 1d12. Because Her Majesty gets an awesome weapon. And a boomstick is a sawed-off shotgun. So it does a minimum of 3 points of damage, right? And a maximum of 12 points of damage, okay? So it's very similar to a halberd, but a halberd you could nick somebody with just a knife. A shotgun, very rarely you're going to do less than 3 points of damage, right? You're going to hit them somehow. Maximum, you're going to do 12, okay? So usually you're going to hit them with something. So that's a broomstick. All right, so we've got all our weapons defined, our gladiators defined. We're going to add them to the arena. All right, now that we've run it, let's see what our arena has. Cool, we got all our objects. Now, objects are annoying, but they're basically gladiators. You can see the attack, defense, hit points, right, in the name. So Jesse's in there, Toby's in there, Brandy's in there, and Bruce is in there. Cool. So we have all our gladiator participants in the arena, and they're going to do stuff, okay? So how do we get them to attack each other? Well, there's two things that are missing. Number one is the algorithm in which they determine their targets. So, for example, I'm in an arena. I see 3 dangerous people. I see a tiger that looks like a big, gigantic sheltie. I see Her Majesty, with a big halberd. I'm not going to take my wife, right? But let's just assume it was life or death. Even if it was, I wouldn't attack my wife. But let's assume that I didn't know she was on. And then I see Bruce Campbell. And I didn't know he was Bruce Campbell, right? I see all these people, and I'm like, oh my gosh, what do I do? I'm probably going to attack the person with the least amount of hit points. I want to attack somebody who, even if they're dangerous, if they're about to die, I want to get rid of that target, right? I'd rather let the other people fight it out and everything else. So we're going to make everyone take the pragmatic attitude of attacking the weakest link, okay? So only the strong survive. So that's what we're going to do. So we're going to say calculate target. So we're going to pass in the attacker and the arena. Now the reason we pass in the attacker is for two reasons. Number one, the attacker cannot attack himself. So we're going to take that array and say, all right, so out of all these people, assuming I'm out of that array, of this list of people, who should I attack? Right? So we need to know who the attacker is so we can remove him from the array. Number two is that later on, we can add different algorithms based on who the attacker is. So for example, most animals, by default, attack the weakest in like any predator or carnivore. If you watch how they attack others in the wild, they always go for the weakest or the sickest or the smallest or the slowest, right? The easiest prey. Because the easiest prey, at the end of the day, ensures their survival. That's just how it works. They're not in it for pride. They're not in it to be awesome. They're not human beings. They're animals. They're hungry. They want to eat. They want to survive, you know, procreate, etc. Right? So that's how the animals work. Humans are different. Sometimes they're very smart tacticians, and they take different approaches to acquiring targets, right? Computers, completely different. So for now, we're just going to say lowest hit points. So first things first, we need to get a different array with us removed. Now we can't go arena.remove ourselves via splice because that would remove us from the arena. We're not dead. We're not leaving the arena. So what we're going to do is going to get a simple copy array. Okay? So we've got a copy arena, which is an arena concat. Okay? So now we have a copy arena. Let's get rid of ourselves. My index is the copy arena.index of me. Index of is just like the index of for array is the same as index for a string. Where's the index of where I occur in this particular array? Once you get the index, you can remove yourself via a splice. Remove myself from that position. Cool. So now I have a copy arena, which is a copy of the other array. Same gladiators, right? The objects are references, right? So even though two arrays have the same gladiators in them, those gladiators are just pointers all to the same gladiator object, okay? The array is different, so I can play with this copy arena and take people out and everything. Now, I need to know which one of these people in my target array has the lowest amount of hit points. The easiest way to do that is via a sort function. Now, we covered this briefly in my advanced arrays, so we're going to do it again. We're going to say take everyone in there and sort them by the lowest hit points. Whoever's the first in that array is going to be the person with the lowest hit points. That's who I'm going to attack. So, we're going to do that. Right now, we're going to say copy arena. So the way we can do this, if we call an array.sort, it'll typically work on strings or numbers, but objects are different. So we're going to have to pass our own little function and say, hey, look, let this function deal with determining who should go in front of who else, right? You do that via sort function. All sort functions follow the following contract, because again, JavaScript doesn't have interface. It's with good faith that you're going to follow the following contract, and that is, if you want A to appear after B, you return a 1. If you want it to be before, you turn a -1. If you don't care, you turn 0. Okay? So we're going to do that. Sort by lowest hit points is a function with A and B. Now, what is A and B, Jesse? Well, A and B will be all the items in the array. The array is going to call that function many times and say, hey, compare this one to this one. Okay. Compare this one to this one. Okay. Compare this one to this one. So it can know how it's supposed to sort things, right? And it does all this internally. It's really fast. All you have to do is tell it how they compare. So if A's hit points or gladiator hit points are greater than B's hit points, then I want A after B. Else, if A's hit points are less than B's hit points, dude, I want him up front. I want him further back, -1. Think of it this way. 1 is further on. It's a positive number, positive index in your array. -1 is less than or goes back in the array, okay? Else, dude, I don't know, I don't care, it doesn't matter, whatever, okay? Now that we have our sort algorithm, notice I defined it inline as an anonymous function. You don't have to do that. I'm just doing it to make the code readable, so when someone's reading this, they can find the sort algorithm right there, okay? Copy arena sort, and sort by lowest hit points. Notice I don't call the function, I say, hey, use this function, dog, to like do your sorting stuff, right? The array itself will call this function. So you can still debug this if you want it, but we're not going to. Now that I have a sorted array, I'm going to return the first item in it. I don't care who that is, I just know that they have the lowest hit points based on my sorting algorithm taking care of it. Now, what happens if they all have the same hit points? Oh well. based on the order I put them in the array and how many times I call it. Doesn't matter. They're technically the lowest. So if everyone has the same, fine. You just happen to be the unlucky person in the first position in the array. And I'm attacking, okay? So notice the last thing we do is return the target of who we are attacking. Cool. So every attacker can now calculate a particular target in the arena that is not themselves. Fantastic. Next up, how do we make this constantly run? How do we make this heartbeat or program run over a period of time? We use a built-in JavaScript function called setInterval. And what it does is it calls a function every few milliseconds or seconds or whatever. Now, who thinks we use seconds? I mean, no one thinks in milliseconds, okay? So the point of an interval is so you can have an operation occur every second or every 2 seconds or every 10 minutes or every millisecond, whatever, right? The key thing about an interval is that it gives you a number back and says, all right, if you want to stop this background process that no one sees in the future, just call clear interval and give me the number, and I will go find that number and stop it for you, okay? If you don't hold on to that number, I can't stop it for you, okay? So it's our responsibility to retain that number. So we're going to call it an interval ID. We only need one because we're only running one of these, right? This interval is going to make our arena fight happen every second, okay? We're going to process through every single one. So we're going to say interval, and in our start game, we're going to say interval ID equals set interval. Now again, set interval is a built-in JavaScript function. You don't have to code it. It's already there for you. It's cross-browser, yada, yada. So we're going to say next attack. This is a function that's going to handle the next attack. Now we're going to add some state to this in a minute. We want this to occur every, let's just say every second for now, so we can see it happening, okay? When the game is over, when do we stop this thing? Well, we only stop it if, let's go to the defender's index. So if they die, we're going to remove them from the arena, okay? They're technically a dead body lying on it, but we don't care about that. What we care about is, are they a participant in the current battle or not? If they are dead, they are not a participant because there's no zombies or magic yet, okay? So arena.index of the defender, remove him from the arena. Notice I'm not getting a copy. I actually really want to modify the original arena array. So splice defender's index 1. Cool, so we removed him. If the arena length is less than or equal to 1 person, so if there's 1 person or no left, the game is over. Now, why is there only 1? Well, we could have situations where multiple attacks occur, and the person, we're not going to get around that right now. We're lucky, but let's just pretend that if they die because maybe they had poison applied, right, that they could die even though they just, were the last person standing, okay? So now we're going to say clear interval, which is the antithesis or opposite of set interval. Clear interval. Learn how to spell, Mr. Ward. Clear interval with the timer ID, interval ID. Then we're going to null it out so it's null, cleaned up, ready to be used again. Okay? So if we wanted to start our game again, we can start and get a brand new interval ID. You don't have to reset this, but it's kind of confusing when you're debugging and you see a number and you're like, well, I thought I already cleared it. Cool? So that's game over, man. So finally, let's define this next attack. This is the function that's going to run every single time or every second, right? 1,000 milliseconds. 1 times 1,000 is another way to write this. If you wanted to do every 3 seconds, you could say 3 times 1,000. It's easier to do that than this in your head, right? That's just a trick I do, others do. You don't have to do it, but we're just going to do 1,000 for now, okay? 1,000 milliseconds equals 1 second. Now, our next attack has to remember whose turn it is to attack, right? Everyone gets a turn. So how do we remember that? What we're going to do is make an index and remember whose turn it is in the arena array. So first person in the array, second person in the array, third. It's kind of like a line. Everyone stands in a line or a queue, right? And whoever takes each turn gets their turn to attack. So we have to remember what that is. So every time the interval is called, all right, whose turn is it now? Cool. Okay, it's changed. Whose turn is it again? Okay, whose turn is it now? Whose turn is it now, right? We have to constantly iterate this or increment this value so we know whose turn it is. And keep track of that. If somebody died, it's now your turn because he's dead. He doesn't get a turn. Right, so we have to remember that. So when we start our game, we're going to reset it to 0. That means whoever's first in the arena is first to take a turn. Whoever's second, it's their turn, so on down the line. Every time we do an attack, we're going to increment it. So let's start it with -1. Right, we're going to start at the very beginning. Next attack is going to calculate whose turn it is. So if the current index is less than the current arenas.length, right, then cool. Go ahead and increment it. Otherwise, we've reached the end of the array. We now have to go back and give somebody else their second turn or second attack. Right, so it'll constantly add to the end of the array and then start at the beginning, constantly add to the array. Now, assuming someone never dies, it'll keep doing this the entire, till the end of time, right? Until my computer blows up good. We just want to make sure that our current index is less than the array's length plus 1. We don't ever actually want our current index to be the length of the array, because if it's 4, that means the last item is index of 3, right? So we want to do plus 1 to make sure that it's bound to that particular point. So we've now determined whose turn it is. Okay, so who is it? The current fighter, current gladiator, is the arena, current index. Now again, current index is dynamic. When we first run our program, this is going to be the first person in the arena. When we run it again, this will be the second. So this interval, every time it calls, is going to increment this number. It's going to be the first person, the second person, the third person, the fourth person, and the first person, the second person, the third person, right? And repeat over and over and over again. It's only going to be different when someone dies, okay? And we have to do some funky math with that. But don't worry about that. Let's just assume that for now it goes forward, and if somebody dies, they might actually get a different turn. And that's okay. We're not concerned with perfection right now. Cool. Who is the current target? We're going to calculate, remember, call our calculate function, calculate target function. So our current gladiator is going to get his target. Okay, so we're going to remove him from the arena, and that is the current defender. Now we're going to apply our handle attack method. Now that we have who our attacker is and who he's attacking, let's actually let the handle attack deal with the facts of rolling to attack, dealing with defense and target minuses, and all the other algorithms for that. And then if they actually calculate the damage, what that is based on the current weapon, and then based on that current weapon, how much damage you actually do, and if you did damage, you're subtracting that from the hit points, and if the hit points are low, remove that person from the actual arena because he's dead, and if all people are gone from the arena except for one person, the game's over, right? This is functions on top of functions, putting in your head cognitive load. Oh my god! Right? You'll get it. It just takes practice, takes repetition, takes good attitude, lots of caffeine, healthy food, good glucose, get your brain moving, all that stuff. Say handle attack. Now notice handle attack doesn't really return anything. I don't care what it does. It's an operation, it just does a bunch of stuff, right? I just know that the current gladiator is going to attack the current defender, and all the other stuff's going to happen after that. Cool. So next attack handles figuring out whose turn it is, finding them an actual target, and resolving the actual battle between them, and then being done and waiting for the interval to take a second and then do it again. Cool. So we have our program running, but we need to see it work, right? We call start game here, but we need to actually see it work. So let's handle that right now. Let's go to the main handle attack, because this is where most of our action really occurs. Okay. We're going to add 2 console statements, one here and then one in our next attack. So you can see the interval happening every second without us having to debug our code. So we're going to say console.log. Just kidding. D. You shouldn't do this, but I love it because it's so much easier to type. So we're going to say D attacker.name is attacking defender.name. Hit. Now, if they did hit for points of damage. Defender has defender.hit points. Hit points left. So again, the beginning of the function, so-and-so is attacking so-and-so. Assuming they did hit, so-and-so hit so-and-so for how much damage, and he has this many hit points left. Else, notice we're only adding an else for logging purposes, which is fine. Missed. So now we have a log there. Let's add one more log in the next attack. Just to see whose turn it is. So we can see each person's turn and turn. Current gladiator.name. Whoops. Turn. There we go. So we're going to change our, let's change it to 3,000. Just make it 3 seconds so it's not so fast. All right, so Jesse attacks Brandy. I miss. Toby attacks me because I have the least amount of hit points. He hits me for 1. Brandy's going to attack me, and Bruce is going to attack me too. Right? So I'm losing hit points. Everyone's going to attack me. Not doing so hot. I hit her. Toby's now attacking me still. If I could hit Brandy, get it lower, they wouldn't attack me anymore. But, oh, I'm dead. So Jesse's gone. I had -2. Bruce hit me really hard for 6 points of damage. Brandy hit her. So as you can see, it's running through. It's dealing with the algorithms, running it. Everyone's dead. So Bruce and Toby are still going at it. Toby has 5 hit points left. Bruce has 1 hit point left. I don't know. I got some money here. I should bet. And Bruce won, because Bruce is awesome with his shotgun. So we can see the arena. Now we've got the last person remaining is Bruce. And our game over, we could probably put a console there, say, hey, game over. But as you can see, that's it, man. Game's over. One person left, calls clear interval, and it's done. So that's a basic program, right? You can see how we're doing with objects. We're doing with objects, creating, giving properties. We can have unique properties and instances, everything else. We can give them each attributes they can play with. So that's the basics of building programs, the basics of taking functions to encapsulate algorithms, and then building more functions on top of them. We have these objects that have complex properties that those algorithms work with. So they inspect those objects and they compare them to other objects. They don't know that they're all dealing with Gladiator 1, right? There's no hard coding. Everything's dynamic. It's just that everyone agrees to go, you know, basically following polymorphism, right? Every single object has a variety of different, you know, functions that they have in the same contract that they follow of hit points, defense, attack. And once everyone follows that same contract, we say, okay, all gladiators have an attack and a defense, and we can calculate if they hit each other or not. If so, what kind of weapon did they use, what damage. All weapons are going to tell us, you know, how they deal damage. They all deal differently, right? All deal differently, but the point is that get damage, okay? And finally, you see how this program actually runs using interval. We can make it, you know, happen over time. We can adjust that. We can adjust all these values and run it multiple times, see what the outcomes are different. And we've done consoles or logging in line, right? So we can actually see our program run and get a better idea of how it's really working. So again, that is objects that have objects within them. That is complex objects. That is functions, objects with functions, defining complex objects and structures with a program and logic around that, and a bunch of nested functions with encapsulated algorithms that we can call to make a program, to make a simulation.